Moving circuits between electrical panels, especially when these panels are part of separately derived systems, raises several potential concerns. A separately derived system refers to an electrical source, such as a generator or transformer, where the neutral is isolated from the main service neutral. This isolation creates a distinct electrical system. When moving circuits, especially without their associated neutral conductors, it's crucial to understand the implications for safety, equipment operation, and code compliance. One key concern is the potential for overheating of the conduit. While a short run of 6 feet might seem insignificant, the cumulative effect of multiple unneutralized conductors in a shared conduit can lead to increased inductive heating. This is because the alternating current flowing through the conductors generates electromagnetic fields. When the neutral conductor is absent, the return current path is not directly adjacent to the supply conductor, leading to a larger loop area. This larger loop area increases the magnetic field strength around the conductors. The magnetic fields can induce eddy currents in the metallic conduit, causing it to heat up. The amount of heating depends on the current magnitude, frequency, and the conduit material. Steel conduit, being ferromagnetic, is more susceptible to eddy current losses and heating compared to aluminum conduit. The National Electrical Code, or NEC, provides guidelines for conduit fill and conductor ampacity to mitigate overheating risks. Table 310.16 and related tables in the NEC specify the allowable ampacities of conductors based on their insulation type, ambient temperature, and the number of conductors in the raceway. When conductors are bundled together in a conduit, their ampacity must be variated to account for the increased heat generated. If the neutral conductor is not present for each circuit, the imbalance in current return paths can exacerbate this heating effect. Secondly, voltage imbalances are a significant concern. In a balanced three-phase system, the voltage between each phase and neutral should be equal, typically 120 volts in a 120/208 volt system. However, when circuits are moved without the neutral conductors, the current flow in each phase can become unequal. This unequal current distribution creates voltage imbalances, where the voltage on one phase is higher or lower than the others. Voltage imbalances can have detrimental effects on equipment connected to the system. Motors, for example, are particularly sensitive to voltage imbalances. An imbalance of just a few percentage points can cause a significant increase in motor current, leading to overheating, reduced efficiency, and shortened lifespan. Sensitive electronic equipment can also malfunction or be damaged by voltage fluctuations caused by imbalances. Three-phase rectifiers, which are commonly used in power supplies, can produce increased ripple current under voltage imbalance conditions. This ripple current can stress the rectifier components and reduce their reliability. Thirdly, ground fault protection is an essential safety feature in electrical systems. It is designed to quickly detect and interrupt ground faults, which occur when a live conductor comes into contact with a grounded surface, such as a metal enclosure. Without a neutral conductor for each circuit, the effectiveness of ground fault protection can be compromised. Ground fault circuit interrupters, or GFCIs, and ground fault equipment protection, or GFEP, devices rely on detecting an imbalance between the current flowing in the hot conductor and the neutral conductor. If the neutral is not present, the GFCI or GFEP device may not be able to accurately detect a ground fault, delaying or preventing the tripping of the circuit breaker. This delay can increase the risk of electrical shock or fire. In some cases, even if a ground fault is detected, the absence of a neutral conductor can limit the available fault current, making it harder for the circuit breaker to trip quickly. This is especially a concern on long circuit runs or in systems with high impedance grounding. Fourthly, compliance with electrical codes is paramount. Moving circuits between panels on different systems may violate the National Electrical Code, or NEC, or other local electrical codes. The NEC specifies requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. Section 300.3 b of the NEC, for example, requires that all conductors of a circuit, including the neutral, be run together in the same raceway or cable. This requirement is intended to minimize inductive heating and ensure proper operation of overcurrent protection devices. Additionally, the NEC may have specific requirements for separately derived systems, such as the need for a grounding electrode conductor to connect the system neutral to ground. Failure to comply with these code requirements can result in fines, penalties, and the potential for unsafe electrical conditions. Before moving any circuits, it is essential to consult with a qualified electrician and obtain any necessary permits and inspections. The electrician can assess the specific risks of the installation and ensure compliance with all applicable codes. Beyond these main concerns, there are additional factors to consider. Firstly, circuit load is critical. Before moving circuits, ensure that the new panel has sufficient capacity to handle the additional load. Calculate the total load in the new panel, including the existing circuits and the circuits being moved. Compare this total load to the panel's rating to ensure that it does not exceed its capacity. Overloading a panel can cause overheating, nuisance tripping of circuit breakers, and potentially damage to the panel components. Also, ensure that the branch circuit breakers in the new panel are adequately rated for the circuits you're moving. Secondly, circuit protection is vital. Verify that the circuit protection devices, such as circuit breakers or fuses, in the new panel are properly sized for the circuits being moved. The overcurrent protection device should be rated to protect the conductors from overloads and short circuits. Refer to the NEC tables to determine the appropriate conductor ampacity and overcurrent protection size. It's also important to consider the interrupting rating of the circuit breakers. The interrupting rating is the maximum amount of fault current that the breaker can safely interrupt. Ensure that the breakers in the new panel have an interrupting rating sufficient to handle the potential fault current at that location. Thirdly, proper grounding is essential for safety. Ensure that all circuits are properly grounded in the new panel. Grounding provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. The grounding system should comply with NEC Article 250, which specifies requirements for grounding electrode systems, equipment grounding conductors, and bonding. In separately derived systems, a grounding electrode conductor must connect the system neutral to a grounding electrode, such as a ground rod or water pipe. Fourthly, maintain proper isolation between systems. When moving circuits between separately derived systems, it is important to maintain proper isolation between the two systems. This prevents any crossfeed or electrical hazards. A crossfeed occurs when voltage from one system is inadvertently applied to another system, potentially damaging equipment or creating a shock hazard. Ensure that the neutral conductors of the two systems are not interconnected, as this can create a circulating current path and compromise the isolation between the systems. Consider using isolation transformers or other isolation devices to provide a higher level of separation between the two systems. In summary, moving circuits between panels on different systems, especially without neutral conductors, presents several challenges. The absence of neutral conductors can lead to overheating of conduit, voltage imbalances, compromised ground fault protection, and code violations. To mitigate these risks, it is recommended, if possible, to move the neutral conductors along with the line conductors. If this is not feasible, consult with a qualified electrician to assess the specific risks and determine if any additional measures are necessary. Obtain any necessary permits and inspections to ensure compliance with electrical codes. Carefully consider the circuit load, circuit protection, grounding, and isolation between systems to ensure a safe and reliable electrical installation. By addressing these concerns and following best practices, the risks associated with moving circuits between panels can be minimized, ensuring the safety of people and equipment. Always prioritize safety and compliance with electrical codes when working with electrical systems. Incorrect wiring or improper installation can lead to serious injury or property damage. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. Remember, safety first.